been told that AI is the most important technology of our time, that's only half the story. Because there is a technology that could break everything we rely on online, and it's closer than you think. Welcome to the age of quantum computing, a new technology that has the potential to solve very complex mathematical problems that are well beyond the limits of today's computers. A few years ago, this was just a lab experiment. Today, it's a multi-billion-dollar global race. Hi, I hope you're doing well. If you're new here, my name is Sarah Kurdi, and I talk about technology, startups, and internet media. I also discuss how new technologies impact our life and society in the context of the Middle East and North Africa region. So if that is of interest to you, then you might consider subscribing to the channel and turning on the notifications bell so that you get notified when new videos are uploaded. I'd also recommend you watch the channel promo to get to know what we're doing here and the type of content you expect to see on here. You'll find the link to the video in the top right corner of the screen. So I started the research for this video with the impression that quantum computers are better, faster, and more sophisticated than classical computers. But as I read more about the actual technology, I realized I was wrong. Quantum computers are not exactly the next big wave of computing. They're just fundamentally different from classical computers. Former Vox producer Cleo Abraham used an extremely clever analogy to explain the difference between quantum and classical computers. Here it is.
Okay, here's the analogy that helps me understand what quantum computers are good for. Imagine that you're on a video game map, and how you get around depends on how good you are at doing math. You may not want to play this video game. Bear with me. So first, there were no computers. Things like geometry and astronomy took forever. So you have your little pencil and paper and you're traveling across the mathematical map by walking. So it was slow. And there were lots of areas that we just couldn't explore because it was beyond our computational ability. But then we developed early computers, and that allowed us to input larger data sets and answer problems that had previously been out of reach. These new computers unlocked new areas on our mathematical map. Instead of walking everywhere, we can now ride horses. We can get farther faster, and we can access areas that were previously inaccessible. But there were still parts of the map that our computers couldn't access. Luckily, computers just kept getting better, and they allowed us to solve more and more complex math problems. As a result, our virtual map has transformed. We have roads and cars, and we're just reaching areas that were previously unreachable. Better computers mean traveling across this map faster and more easily than ever. Quantum computers are not faster cars, they're boats. A boat is not necessarily better than a car. They're just built for totally different terrain. So with our new quantum computers, we're beginning to navigate these new mathematical waters, solving problems and discovering areas that traditional computers just can't.
So what exactly is a quantum computer, and how does it differ from the computers we use every day? First, to understand what a quantum computer is, we need to understand how the normal computers we use actually work. So your smartphone or laptop works with these tiny on and off switches called bits. A bit can be either 1 on or 0 off. Everything you see and use on your computer, all of the videos, apps, or games, are just millions of these zeros and ones. A quantum computer, on the other hand, uses quantum bits or qubits. This is where things get interesting. Bear with me. So a qubit can be either a 0 or 1 or both at the same time. The fact that it can be a 0 and 1 at the same time comes from a concept in physics called quantum superposition. To understand the difference between bits and qubits, think of it like this. A normal bit is like a coin lying flat, heads or tails, while a qubit is like a coin spinning in the air, both heads and tails at the same time. Want to see what a quantum computer looks like? Here's Olivia Lane's global lead for quantum learning at IBM, showcasing IBM's quantum computer.
Oh, that is extraordinary. This is what System 2 looks like inside?
Yeah.
What are we looking at then?
I think a lot of people have a slight misconception and they see, this whole gold shiny thing and they think this is a quantum computer. That's actually not true. This is the quantum computer. So this tiny little thing, right?
But why is everyone suddenly interested in quantum computing? In a recent blog post, Google urged banks, governments, and technology companies to be prepared for quantum computing hackers capable of cracking most existing encryption systems by 2029. The tech company said the encryption currently used to keep your information confidential and secure could easily be broken by a large-scale quantum computer in the coming years. Just so you understand the scale of the quantum computing threat, when we say encryption, we're not just talking about securing your emails and WhatsApp messages, but we're also talking about sensitive government information and banking transactions. Basically, the potential collapse of the current global digital infrastructure as we know it.
Few are more afraid of a mass global data breach than the banking industry. Dr. Philip Interlura is head of quantum technology at HSBC.
We process £3.5 trillion worth of payments every year. So cryptography is a big deal for us.
How much of a catastrophe would this be if people just sat back and did nothing?
Well, ultimately, you're going to have customers' accounts being breached, which means things like identity theft and fraudulent transactions.
Money being stolen?
Money being stolen. That's then going to roll into financial losses. Customers will lose money, the banks will lose money. But I think ultimately the biggest risk of all is the element of trust. If customers can't trust their bank to keep their accounts and their money secure as well as their data, then it's kind of an existential risk.
Yeah.
But I think it's a bit early to be worried about your banking information. Yes, quantum computers do exist. Companies like IBM, Google, Microsoft, and SpinQ have developed operational quantum computers, but they're still in the very early stages of practical applications. Building a quantum computer with hundreds of thousands or even millions of stable qubits or quantum bits will require overcoming physical and technological challenges to keep those qubits stable because of the fragile nature of quantum systems. These systems are insanely difficult to build because they require, for example, massive amounts of helium to cool quantum systems to near absolute zero temperatures, or weeks of work aligning lasers. Plus, the quantum computers we have today are too small to perform the tasks we're worried about. Quantum computing is expected to revolutionize industries from cryptography to artificial intelligence. As investment and research in this field continue to increase, we're likely to see a quantum future much sooner than expected. If you like this video, then you might also enjoy the video where we discussed how social media platforms impact our creativity. You'll find the link to the video somewhere on the screen. That's it for this video, and I'll see you in the next one.